and welcome back to another episode of Duty Calls.
Yes, you've got your laptop out.
I do. We are doing clip breakdown again today, and we have some exciting news about what we're covering today, if you want to talk to them about that a little bit.
Yeah, so this video we're going to kind of cover the installation, the sledgehammer unit that we installed out at Canopolis Lake. We talked about doing like a on-site, I don't want to call it an interview, but like where we were talking and explaining exactly what we were doing. But unfortunately, it has been extremely windy this past 2 weeks when we're filming this, and it was especially windy out on site. There was dust blowing everywhere, and it wasn't going to be very good for any kind of audio.
No,
so
it was less than ideal.
Yeah, so we just did the video. We're going to put that up here, or you just finished editing it.
Yeah.
So we're going to push that out, and then this just really kind of hoping to kind of explain what we're doing as we're doing it from the video, and then also show you guys and explain what you're looking at when it comes to what this product is, what the technology is. So without further ado, let's get started.
All right, let me hit record here, and we're good to go.
All right, so I took this part of the video, and I'm pretty proud of it.
Yes,
so.
he's very proud.
If you want to pause real quick here. So right now, it's just, we got the equipment there, the gravel and pipe and stuff. But I did want to touch on where we were putting this in. I know we kind of touched on it one of the previous duty calls.
Yes.
But we are out at Canopolis Lake in the Venango area, and we're right off the highway there, right before you cross the dam on the north side. And there's, I don't know how many houses are in there.
Quite a few.
There's quite a few houses up there, and this specific property, like most properties there, just had 2 holding tanks. And with holding tanks, you have no form of absorption field, no lateral lines, nothing. And so what that means is, this one had 2 1,000-gallon tanks, and they were in series. And so after they used 2,000 gallons capacity, they weren't going to be able to flush again until they got those tanks pumped out. And that can be costly, especially if you're going to use this property, if you're going to use the property on a regular basis without, really conserving your water usage. And this property specifically is going to become a rental, an Airbnb or a cabin of sorts. And so that cost, would really add to, it would really affect the overall cost of owning the property.
Right.
And so by putting in the sledgehammer unit, we can convert the 2 holding tank system without an absorption field and install an absorption field. So there's much less pumping needed, at least not every time you use 2,000 gallons. This system specifically is designed to treat 1,000 gallons per day. We overestimated the size because it is a rental property and we don't really have any past water usage data to go on. So we wanted to oversize it as much as we could without, becoming
too much.
Yeah, too much. Yeah. Unpractical, I guess, but or impractical. Unpractical. What am I thinking? But anyways, so we sized this based on 1,000 gallons per day, and so we were able to put in the absorption field, and that way, they don't have to pump it. We just have that system in there. It's just running. So anyways, let's continue. I ramble a lot, so there's our pump truck. All right, so this is the unit itself, and this is what goes in the tank. We were able to utilize, instead of like tearing out the 2 tanks that were there and then replacing them with a whole new tank, this unit fits inside the riser, the opening of the existing holding tank, and we put it in the inlet tank, the first tank, put it in the inlet side, and it goes in there and it treats and absorbs, or not absorbs, but it treats and it breaks down and digests the solids and the wastewater coming into it. And then that second tank, which we'll show you here in a second, we turned that into a pump tank. So yeah, that's the unit itself. It fits in. It's very scalable. It's much more cost effective in a lot of scenarios because, given, as long as we meet certain requirements in terms of sizing and conditions, we can utilize the existing tank that you have. We don't have to always put in a brand new tank. So that's one part that's really, really cool about this technology. But that is the unit itself. That's the kind of the heart and soul of the sledgehammer system.
All right, I'm gonna keep it going here.
And there's our pump truck. So we started we started with pumping out the tank, the existing tanks. They did have a little bit of wastewater in them. The first tank I would say was probably 3/4 full. Now these are just holding tanks, so they don't have a lot of accumulated solids. They don't have a lot of accumulated solids, but it's good practice to pump them out, and that way we're starting out with clean water, and then as they use the system, they'll add the wastewater, and we can take samples and do all that kind of stuff. So. Mm-hmm. And then kind of jump forward a little bit here in the video, but we're starting on the absorption field, and with the setback distances from the property line on the video on the left side, and then the foundation on the right side, we had very, very limited space to work with. Mm-hmm. To meet all of the setback distances, we were only able to get about a 6 to 7 foot wide trench, and it goes about 60 foot long there in front of the house. So, and this is just starting out digging it. So. Mm-hmm. You guys have seen a lot of this, I know.
Yeah.
Anyways, digging it. And there are a couple, those blue lines, that was an old abandoned sprinkler system that's there. So, and then there's me. I am cutting down conduit. So I was cutting the conduit for the electrical service for the pump that went in this tank right here. Mm-hmm. So, or is that the half inch? I think that's the half inch. That might be the.
Well.
Oh, anyways.
I think you'll see it when I.
Yeah.
Go out a little bit.
Okay, so the conduit's there.
Right here.
That would be a visual of the second tank, the pump tank. That tank, it was just a holding tank before. It had no outlet in it at all. And so in order for us to, number one, meet elevations, and number two, be able to control the dosage to the field, this field is going to be pressurized. So that's 1.5 inch PVC coming out. We have our ball valve there in the riser with the union, and then the effluent pump, which isn't in the tank yet, that goes and sits in the bottom of that second tank. So it goes in the first tank, it meets that sledgehammer unit, and then it's going to flow into the second tank where it's then pumped out on a demand dose basis to that absorption field that we were digging. Yep, keep going, sorry.
Yeah, sorry.
And more sprinkler lines.
Jumped around a little bit.
All right, so that's the half inch, and you can keep playing it, I think.
Okay.
So that's the half inch, and that's what supplies air to that unit right there. So that long stick of PVC I've got coming up out of it, that's part of the air supply. We put it in the unit before we set it in just because it's a lot easier and closer to get to. So we're going to set that unit in there, and then we'll hook everything up with that half inch air line coming from the aerator box, which is sitting right behind me, right down there in that green box.
My little timer bar came up, but right here, circling that with the mouse. But I do have a picture of it.
So that has a little, but that box has a little air compressor in it, and that's what supplies air through that PVC that we were just gluing up into the unit, and that's what that's part of the treatment process. So we're converting the tanks from anaerobic to aerobic. So we're gonna set that in, I think, next, right?
Yeah.
So as you can see, it fits in the existing opening. We don't have to special order tanks or build a tank around the unit or anything like that. And then that there, you want to pause it? Maybe rewind it just a little bit back to where we were.
Just right about here.
Yep, that'll work.
Cool.
All right, so that starfish spider-looking thing. That is, in this system specifically, in order to achieve that 1,000 gallon per day treatment, the unit itself is an S86, and that is suitable for up to 600 gallons per day. With the addition of that secondary air diffuser, we are able to achieve a 1,000 gallon per day total treatment capacity. And I think, if I remember right, the sledgehammer unit itself, by itself, will do, I think it breaks down like 3 to 4 pounds of solid. It'll digest 3 to 4 pounds of solids per 24 hours. And then that will add another, maybe I'm wrong, maybe it was like 2.5 to 3 pounds, and then that'll add another pound to 2 pounds of digestion per 24 hours. So overall, we were looking at like 4 to 5 pounds of solids could be digested in any 24-hour period. So, and that's it. Just there's a hose connected to it. You can kind of see it. That we just teed off with a ball valve to the air supply going from the single compressor to the main sledgehammer unit. We were just teed off of it, and we kind of offset the diffuser from the unit in the tank, and they both bubbled. So, and that's the mechanical side of this system. Sorry.
Oh no, I just didn't want to.
So very scalable, very compact unit, very economical when it comes to being able to utilize the existing equipment and all that. So, oh, you can keep playing, sir.
Oh, okay. I just wanted to make sure.
So now we're just gluing everything up. Need both of us for that big pipe.
Oh, I'll pause that.
So that is
right in here.
yes. So that is the bug bag. And so sledgehammer, we kind of touched on this in the previous video, but sledgehammer's technology involves two different treatment processes that kind of work together. And the first is mechanical, and that's with the introduction of oxygen into the system, which is what we were just gluing up. The second is a biological treatment using their bug bag on the bug stick that I've got in my hands. And that goes down and sits inside that sledgehammer cylinder, that unit, and it treats the wastewater both biologically and then also mechanically. And that's a proprietary special blend of bacteria that they've spent years and years and years researching and developing. And so that's their thing, and that will get replaced once a year. And it's just zip tied on there. You can just cut it off and replace it. So anyways, we just glue it to the stick so that we can get easy access. So, and there it is before it goes in, and as you can see, it's just going to kind of sit right down in there. So, and then that's me, and that. So we got everything with the sledgehammer unit set up. As you can see, the green aerator box there to my left, or to the left of the screen, with the control panel set. That's all backfilled and everything. And what I'm doing now is I'm building the pumps, or the pump and the flow tree. So we're just going to set an effluent pump, and that's what allows us to dose the field from the holding, or from the formerly holding tank, now pressure tank.
Okay. I'm always half afraid it's just not going to play again.
So just lining everything up. And it really wasn't that dark out. And there we're just tidying up. I'm just tidying up all the cables and everything.
It was cloudy the second day for sure. It
Yeah,
started sprinkling a little bit.
It was sprinkling, but then with the wind, there's so much dust flying.
Yeah.
I had to put my hat on backwards. Shout out Erwin.
Yeah.
Had to put my hat on backwards because I kept losing it. So yeah, we got the pump in, and then the power line coming from the pump, and then that is the float tree. Pause it.
Okay.
So the float tree, on all effluent pumps that we install, I really hate just putting like an outlet near the pump to plug it into, because number one, it's not a very good way to supply power to a pump, in my opinion, because it's out in the elements. You got water, you got all kinds of different stuff that can cause problems, animals, and then the other part is that running power from a control panel located at the house is a lot easier to install alarm float. There we go. It's a lot easier to install an alarm float, and also to control the water level and how much you're dosing, especially if you're doing time dose. Time dose, about the only way to do that is with a control panel. Most of our stuff thus far has been demand dose. But the alarm tells you if the pump ever stops working. It'll tell you ahead of time before you start actually having problems in the house. And so we default to always putting in a control panel with an alarm float. So that is the unit itself. It's not completely full. The tank, we didn't quite get it up to operating level yet, but we just turned it on to test for air leaks and all that kind of stuff. But yeah, that was what it looks like before the water covers it, bubbling and doing all the good stuff that it does. And that is your slow-mo.
Gotta love the slow-mo. They're just, it's my favorite. They're just really fun to watch, I think.
Yeah, and this was just a conventional in terms of what we did. This is just a regular gravel field. We had 12 inches of gravel there. Now, this part was interesting. This was at the county sanitarian's request, the way we did the field. So the field is pressurized, very much like an LPP system, or low pressure pipe system. And what that consists of, we need to do one on the property from Holmes or Country Club Road. That was the first LPP system we put in. First one in central Kansas that I'm aware of, actually. But
I did film a video of that. I'm not sure if I ever uploaded it.
Okay.
But I do have something.
Yeah. Anyway, so an LPP system, they're not very common around here. They're common in a lot of other places, but they're not very common around here. But what it consists of is, instead of running the 4-inch perforated pipe that you see here, you run 1.5 inch perforated pipe, but you make the perforations. And we use a 5/32 bit drilled every 5 with a hole drilled every 5 feet. Now this system specifically, we wanted to pressurize the field to be able to utilize the entire field, which is part of the benefit to an LPP system. However, this setup, this design did not follow most of the specifications for how we would design an LPP system. But what we did, because this soil out there is extremely sandy, after you get a foot or two down, it's like playing on the beach, really. I mean, it is just pure sand as deep as you can dig. And so because of that, wastewater in a gravity system only travels just a little bit at the beginning, and it ends up going straight down into eventually groundwater. So if this were gravity, it wasn't really possible with the tanks, but if this were gravity, you know, that 60, 70 foot that we ran, only about 10 of it would ever actually be utilized. And so the rest of it is basically a waste at that point. And so we pressurize this system so we can get equal distribution throughout the entire line. Now, because it was sand at the sanitarian's request, we ran 4-inch perforated pipe around, we ran the 1.5 inch through the 4-inch perforated pipe. So through the 1.5 inch squirts upward, and then the 4-inch has the holes on the bottom side at 8 and 4 and 7 o'clock, 8 o'clock, 4 and 8 o'clock. Yeah, they have 1/2 inch holes at 4 and 8 o'clock on the pipe, and so the wastewater will squirt up to the bottom of the top of the inside of the pipe, and then it'll come through the bottom. So it'll be like a gravity fed system in a sense, but it'll be pressurized, so we'll get wastewater throughout the entire thing.
Keep that going.
All right. Yeah, we're just gluing all that up. See,
Just
there's
a little more.
Yeah, us running it through.
Yeah, you can kind of see it right there in the middle. Gotta love my slow-mo and time lapse.
Oh yeah. So
Whoa.
okay.
Oh, here, I'll pause it right here, actually.
Yeah,
So
so
you can see something.
that first, if you want to rewind it to that first one just real quick, we can kind of cover a little bit more of what we're doing there.
Man, it's like real bright.
So that is the completed system. Again, it's still bubbling. We don't have the tank quite up to operating level. We're about a foot maybe under. But what you've got is the 1/2 inch PVC coming in. We've got our union there so we can disassemble everything for easy service. Pull the unit out, the sledgehammer unit out if we ever needed to.
Mm-hmm.
So you've got ball valves there. The other one's going to that secondary air diffuser with the rubber hose, and then the bug stick. So, and it's bubbling in there.
Mm-hmm. I'm not sure why it's so bright.
So this tank's a single compartment 1,000-gallon tank. We followed it up with an effluent filter. Effluent filters should be in every system. And then we've got the completed and pressure checked pump tank or pump chamber. So this is an entirely separate tank. We had the tank there, so we utilized it to just put the pump in. It's also 1,000 gallons, and it's going to dose approximately 100 to 150 gallons every time the pump kicks on. So we got our electrical coming in with some waterproof connectors, followed by an independent float tree. So if we ever have to pull the pump, we can just unhook that union and pull the thing out. Or if we ever have to pull the floats, we don't have to pull the whole pump. So I really like that setup. It's a lot easier for future service if we ever do have problems or ever have to, pull a pump or the floats or anything like that. It's a lot easier than pulling everything out all at once. So anyways, that's that. So there is the air compressor. So it's really not very big. It just it has a rubber hose connection there, and then we have a union just on the outside of the box, so if we have to pull the pump or replace it or move the box or do anything like that, we can disconnect everything. But other than that, and then there's an alarm on the pump. We left it attached to the air compressor, the air pump. There was really no need to take it off, I didn't think. So you could definitely hear it, and that alarm basically is if the pump ever stops running or has too much pressure, back pressure coming against it for whatever reason.
Okay. And do you think I have a couple more pictures here?
Okay. That's just a picture. So the pump itself has just a regular 110 plug-in. So we ran an outlet utilizing the existing service connection. We ran an outlet, a waterproof outlet to that, and then the aerobic control panel. That it's mislabeled. It's actually just a simplex pump control panel, but that is that's the control panel that has your power to your pump, your float, and then your high water alarm. So did you get the inside of it? Yeah. So there's the two breakers. The one's for the pump itself, and then the other one is for the high water alarm. So if we have to kill power to the pump for whatever reason, or the alarm, you can do it from there. So.
Oh, okay.
Yeah.
And I think I have one
final overview. So that's the sledgehammer box, or the air compressor, the box that it sits in. So that's what that is. And then this is kind of the finished product. We're going to go back and I think we're going to reseed it and straw it here in a little bit. Again, the wind's been blowing like crazy, and planting isn't the best, but that's what that's kind of what the property looks like after we Harley rake everything, backfill, grid everything out. So we really pride ourselves on leaving the site as clean as we found it. We had to remove 3 different landscaping features. We had the gravel that was up by the house that the air compressor is sitting on. We removed all that, trenched under a sidewalk so we didn't have to cut any concrete or anything like that for the conduit and the air line. And then coming from the pump tank to where the field started, we had to remove a paver's walkway. And so we were able to take that apart. We saved all the gravel, we saved the pavers and everything, and put all of that back. And then there was out in the middle, there was like a paver's planter that we disassembled. We haven't put that back yet. I don't know. The homeowner said that she may not have us put that back, but if we do, we'll go back out whenever we reseed and straw the area to try and get grass seed back there. So, but that's it. Sorry.
Oh, no, you're fine.
But that was the unit. It was a lot of fun. It was really interesting.
Yeah, learned a lot just from being out there. Filming, anyways.
Yeah. That like we saw in the video, and after getting hands on with the product, it's a fantastic option for any application where an aerobic system would be, suitable or a good option, because it is so scalable. It is so retrofittable. Into existing systems or even into new construction systems. So if you're building a house where you need an aerobic system, or where you're over a protected water area, or the soil conditions aren't the best for a conventional system, this is a lot faster and more economical option that still achieves a very, very high wastewater treatment quality compared to getting a different brand or a different manufacturer involved. And then also the retrofitability from being able to utilize existing equipment and either restore a failing system that's failed due to biological or organic overload, it's failing biologically, or in this kind of case, converting like a holding tank system into a septic system essentially with a drain field. So. Yeah, it was fantastic. There's a lot of different applications, also commercial treatment applications as well, which we may get into here eventually. Depends on if any commercial facilities go up or start having problems. But it's a fantastic solution for a wide variety of applications.
Yeah, absolutely.
I hope that explained. I ramble a lot, but I hope that kind of explained what it is that you're looking at. It's they're different from a conventional system, but another thing that we probably should touch on at some point is maintaining aerobic systems. Differences from different brands. We could probably get a film, like an on-site film on how we maintain. We've got a commercial hoot system that we maintain on a monthly basis, so we could probably get a video on the step-by-step process that we go through with that.
Yeah, we can do that.
And then, compared this sledgehammer unit compared to one of those units, they achieve, the end goal is the same in terms of how they operate, but maintenance-wise, this is going to be fantastically easy to service. We're going to take sludge levels, we'll replace the bug bag every year, clean the air filter, we'll clean the effluent filter, and we'll make sure that the pump operation's good and that we're still getting air to the sledgehammer unit, the diffuser in there. And that's pretty much it. I mean, it's extremely simple. So compared to other systems with computers and memories and codes and multiple filters and disk filters that clog up every other day, it seems like. So I'm really excited to keep learning more, but also to keep keep putting these systems in the ground. So it's going to really open up. There's so many options for it, so many applications where it's beneficial to the homeowner, it's beneficial to the end user, and it's also beneficial to the environment. So because we're getting a phenomenal wastewater treatment quality coming from it. So anyways, like I said, I rambled, but I'm very excited.
Yeah, I mean, I think that pretty much covers it for this week's clip breakdown.
Yeah.
So, I mean, other than that, thank you guys for watching. And if you guys have any questions, concerns, or just want to chat, just put it down in the comments.
Like, share, comment, subscribe.
Yeah, what he said.
All right, that's the fee. You learned a lot. That's the fee that you have to pay now is share it with somebody if you learned anything. If you didn't learn anything, then
that's fine too, I guess.
That's fine too, yeah.
Well, thank you guys.
Thank you.